Welcome back. We are starting now. Steen. Shh. Joshua. Joshua. We're starting now. Yay! Okay, so I'm very excited to introduce Ibrahim Elawadi from Greenpeace, all the way from Amsterdam, the Netherlands, who'll talk about current landscape of modern data stack, what it means and what implication it has on analytics. And also maybe we could all think together, try to anticipate, maybe try to predict how it's going to influence the future and how it's going to influence the analytics field overall. So with this, let's welcome Ibrahim. Big round of applause.
Thank you. I think this one is not working. Is it? Can you hear me? Yes. Oh, perfect. So, hi everyone. This is actually my first Super Week, and I actually know maybe 2 people in the room. So let me start with a very quick intro about myself. So I'm Ibrahim. I'm Egyptian, living in the Netherlands with a wonderful wife and 2 kids. I'm electronics engineer by study, but I shifted that study a little bit toward the marketing at some point with a master's in marketing, then shifted it again to more of the astronomy side of things. And I'm actually an astrophotographer, so I get a few medals in astrophotography. So if you want to chat about how to shoot the stars, if you ever wonder how you get these pictures, just get back to me. And I'm working as a senior insights advocate with Greenpeace, which is a global organization that works in protecting the future of the planet with over almost 100 million supporters across the globe. And I'm part of the global insights team that works on measuring how can we protect the future somehow. I'm also the co-founder of Trackify.ai, which is a web analytics solution that will be open source, and we are hoping to launch it very soon. Maybe this is the first time we ever say that publicly, but I hope it will add a unique value to the industry. Now, I have a warning before I start. So sometimes when I get nervous or excited about something, I tend to speak really fast, and I mean like really, really fast. And I'm actually both now, so I'm nervous and excited. So if you feel that I'm speaking too fast, English is not my first language, and I believe it's not for most of you, so please don't hesitate to maybe wave with your hands like this or ask me to slow down if you feel I'm going too fast. Okay, to the modern data stack. We hear that term a lot in recent years, maybe starting 2017, 2018. This term started to pick up with many articles posting about it, with many people talk about it. If you just look at the last 3-4 months, we have 3 different conferences talking about the same topic, which is quite interesting. So what is the data stack? Is it like a set of tools that we can use to do something with data? You know, something we stack to deliver some sort of value? Is it some sort of like data architecture? Is it like maybe a mix of both? And what makes it modern? So to answer these questions, I think it's really important to understand how did we get to this point, looking back at history and see how things built up to the moment that we live nowadays. Because this is the only way that we will really understand how to leverage this point and will give us the ability to predict the future and where all of this is going. So once upon a time, and around the year 90, toward the end of 1990s toward the end of 2000, a lot of things has been happening in the world. So there was this dot-com boom with this new thing called the internet that is growing, and everyone is investing on it. A lot of companies are coming up with things, and then it kept growing, and then like in 2000, all of that this had like a massive crash that I hope it's not happening anytime soon. But like with all of that was happening now in these days, something interesting was really happening under the hood. So the world was becoming connected. It doesn't matter what companies like rise back then and what fall, what disappeared. What really matters is that at this moment of time, the telecommunications companies have been investing heavily in the technical infrastructure that is holding the internet nowadays, which is the massive network of cables that's going across the globe. Okay, so this is the first point that I really need you to remember, that this was the first key turning point in the history of the internet, or the history of the data stack, as we'll see, which is a fall in the prices and cost of the fiber optics. And this is what take us to this moment where the world is flat. And this is the moment where, I think the audio is not working. Can you hear this voice? I think many of us remember this beautiful symphony of music that when you hear it, you feel that the world is opening in front of you. And I want to show you, like, just for a minute, an interview with Bill Gates that goes, I think, to 1995. That was really interesting. I hope the voice works.
What about this internet thing? Do you know anything about that?
Sure.
What the hell is that exactly?
Well, it's become a place where people are publishing information.
Right.
So everybody can have their own homepage. Companies are there, the latest information. It's wild what's going on. You can send electronic mail to people. It is the big new thing.
Yeah, but you know, it's easy to criticize something you don't fully understand, which is my position here.
Go ahead.
But I can remember a couple of months ago, there was like a big breakthrough announcement that on the internet or on some computer deal, they were going to broadcast a baseball game. You could listen to a baseball game on your computer. And I just thought to myself, does radio ring a bell? You know what I mean?
There's a difference.
There is a difference.
It's not a huge difference.
What is the difference?
But you can listen to the baseball game whenever you want.
Right.
Too.
Oh, I see. So it's stored in one of your memory deals,
Exactly.
and then you can come
That's
back
the RAM
a year
thing
later.
you talked about earlier.
Yeah. Do tape recorders ring a bell?
So, yeah, what I want to say from this is, you know, this is just in 1995. So this is almost 27, 28 years ago. It's not 100 years ago. It's not 1,000 years ago. This big new thing that, like literally control everything in our lives nowadays was the big new thing 20-ish years ago, which is really fascinating. The other part that was really an important turning point in this history is the year 2003, 2004, 2005, 2006, and 2007. And I think this couple of years has been extremely important in the history of the internet and the history of the data stack. So in this year, Facebook went public, Twitter went public, GitHub went live, Airbnb went live, Netflix streamed its first movie, and Steve Jobs announced the iPhone. And you know, with all of these technologies, what I want you to focus on is not the actual service, it's the infrastructure that is getting generated, the demand that is getting generated with these services going in. You know, having this iPhone, the iPhone is not about the Apple products, in case you hate it, but it's just about this idea that we are looking differently and at phones. Like previous, you know, period to the iPhone, we used to use phones to make phone calls and send messages. Maybe there has been some attempts to do something different, but the iPhone was the first one to bring that to the mass and looking into the idea of having, maybe I can open the internet and have a browser on my mobile. Maybe I can install apps and games that do different things, which if you think about it is really fascinating. So at this moment, also, and there has been something also important that happened at this moment that we'll talk about in a bit, but one of the most important things that happened due to this movement and massive growth was collapse in the prices of storage, smartphones, and, you know, integrated chips. So at the first stage, before the year 2000, we have fiber optics that was now everywhere. In the second stage, at the year 2000, we have now storages that became much, much cheaper than we used before. At this moment, the world became really big and fast. And I want to bring also your attention to something. You see, like, in this computer here is you know, the IBM 704. I think that was like the 50s or 60s. And this computer was able to do, you see, it's like 10 tons machine that fits like a big room, and it's able to do 12,000 floating operations, like arithmetic operations, which at this moment was really fascinating. But I want to show you this. So this is like a Raspberry Pi device. You know, you can buy that, I think, for less than 50 euros. And for this one, I think it costed maybe 3 million. And this one, so this one is able to do 12,000. This one is able to do 1.8 billion operations. So this one in my hand, and actually not all of this, it's just this black small box here, is able to do 150,000 times what this massive machine was able to do in a fraction, in a nothing compared to that cost, because of all the development that we are having. And I think this is something really fascinating that maybe we take for granted today, but we should really look at how all of that came to be. And you don't even don't need to look at that. If you look at your phone, at your pocket, if you look at the, let's say the 815 Bionic chip from the iPhone, the latest one, this one is able to have 6 cores, not 1, 6 cores. And each core has, I think, 2.2 billion operations per second. And all of that is just at this stage. At this very small chip here, this small box here is having almost 15 billion transistors in a very small place. So I think this is really very important to understand. Now, what matters to us at this point is something interesting that happened to the tech industry, which is, Google is getting very big, Facebook is getting very big. All these companies started to have a challenge with the existing database systems that we have. Facebook, Google now went global. Now they have a massive increase in their number of users. Google want to organize the information of the world. That's their vision. And they try to connect as many data as they have. So how on earth can you give a user the ability to search billions of websites and return results in milliseconds? How can you do that? With the existing technologies that we had back then, they was not able to do that. And they had to invent something new to do it. And that something was Mapreduce. And Mapreduce was this very nice idea and brilliant idea that Google published in 2003. And it says, you know what? Why do you have to analyze the same data, to bring the same data into the same location as one big chunk and go through it all? That's very expensive operation. So why don't we split it over multiple machines and multiple storages? And then these multiple machines, each one of them will go through this part of the database, and all of that will return the same result. And this is how Hadoop was born. It was then adapted by one of the Yahoo engineers back in 2005, and then what we use today in many of our big data work is originally going back to that date. Another interesting thing that also happened on the same time is we started shifting into the column-based databases. Now this is very important, and it's really affecting everything we do nowadays. So if you look at the database at the top here, you see, this is how we see data in any database management system. But how this data is stored in the storage system matters, and I will tell you why. You see, like the normal way of doing things is like if you open a CSV file with a text editor, you will see that everything is just comma separated, row by row and field by field. So you see here that we have, India chocolate 1000, that's India chocolate 1000. So you go row by row. This is the way that things are stored in memory, like either, like a permanent storage or like RAM. And this is another way of thinking about it, which is why don't we do that column by column? So instead of storing that in the disk, India chocolate 1000, we will store it India, Germany, US, and then chocolate, ice cream, chocolate, noodle. So, but why does it matter? I don't really care about how it's stored in storage. Well, it turned out that this is really important, and it's really affecting our analytics work. Because if you think about it, most of your analytics operations is really going column by column, not row by row. You would usually want to do averages of things. You would usually need to go, so if I want to take the sum of sales, I need to go column by column, like item by item in the columns, right? Not row by row. What if I want to sum 1,000 plus 2,000 plus 4,000 plus 500 in a row-based database? I will need to load the entire thing in the database first to be able to get that column. This is why you see in some database technologies, like for example SQL, is really good and super fast when it comes to joining tables. Because you are doing this operation on a row level, you are just joining 2 tables. But when it comes to column, it's way, way slower than other technologies like Pandas, for example, if you do the same operation with Pandas, or if you're doing the same operation with any cloud-based column database like BigQuery. So that's another thing that was really important, and it had a significant impact on the rise of the modern data stack. Nowadays, our world is becoming much smarter. So there is this, everything is now deep neural networks, deep learning, deep whatever. Everything is getting really smarter, and everything is really connected to a way that was not happening before. And with that, we have a massive collapse in the prices of the sensors, and the world is now massive and smart. And at this moment, beyond the year 2010, the data lake was born. And the data lake is a very simple idea. So it says like this: let's just throw everything into one place. and hope that something good will happen out of this. Okay? So we have structured data, like your sales records, your customer records, your whatever, any kind of like data that you have, just throw it on the same database. And you have images, okay, put it there. You have audio files, okay, put it there. Just put everything in one place. Because we want to break silos, right? This is important. We need to connect things together to get something useful. We don't know yet what's that thing that we will get out, but we need to do that first. Let's just put everything into one place. And now we have structured and unstructured data having into one place, and we centralize things to innovate. Now I'll come back to that later. But anyway, at this moment, something also very, very interesting happened, which is the rise of the cloud. That was around the year 2012. This is where things started to get really interesting. Because now we have these vendors that already use the cloud with massive infrastructures like Amazon, Microsoft, Google, and they started opening their technologies as a service to other people. You know, if these technologies are really good to power my Gmail, and the search engine maybe it's really powerful enough to run my enterprise and, you know, provide value. And this is where everyone started opening that. And one of the most interesting ones that we really care about is this one, Snowflake. Because Snowflake in 2012 was the first one that provided an enterprise-level data warehouse. And the data warehouse is not a new technology. It goes back to the 80s, I think, and the same with column-based technologies. But the good thing about this one was the ability to provide that on the cloud, which was really innovative. Now, let's take that step by step to understand what is really the data stack, the modern data stack. So just recap of everything we said. We have now the world is connected as never before. We have fiber optics, connecting everything together. And then we have storages that is very cheap and very affordable, and it's available for us through those cloud vendors. Okay? And we need to do something with our, with our data. So we start from the data sources. You see, all of us deal with, in our day-to-day work with, customers' data that is either, like in Salesforce, HubSpot, whatever. You have the Google Analytics data, you have the Shopify data, you're probably running Facebook ads, and you are running, Google ads. And the first thing that we want to do with this stuff is probably bringing that into somewhere. So I want some way to connect that, because I don't want to use Facebook Insights, I don't want to use the Facebook ads reporting interface, and I don't want to use the Google Analytics. I need to bring this data from these platforms to do something with it. Okay? So the first step, this is where the first layer of the data stack was born, which is the data ingestion. And these are the couple of tools that started to pop up, providing the ability to connect the data from different sources. Here's actually a combination of sources itself and also tools that do this kind of like ingestion. And ingestion is just a fancy way of saying bringing the data in. And you see that we have also not only the paid versions like Supermetrics and Fivetran and Stitch, we have also open source tools that started to grow rapidly in the recent years, like Airbyte and Snowplow. So we got the data in. What do we want to do now? Well, I cannot hold it. I need somewhere to store that data in. So we have the data storage layer. And the data storage you can pick from a lot of cloud solutions like Google Cloud, AWS, Azure, Databricks, and Snowflake, depending on the thing that you're trying to achieve. Okay, we got the data in. What do we want to do now with it? We want to do some transformation on that data. Okay, so we have the data transformation layer, and with that you can use dbt, you can use Spark if you're dealing with big data, and you have many other technologies. Okay, we transform the data. What do you want to do next? Well, I'm not sure if the data is in the quality that I need to use for my work. I need to do quality check. And now I have data from different sources, so I need to do some sort of governance and etc. So at this stage, we need the data quality, governance, visibility layer, which we have a lot of brilliant tools like Great Expectations and Monte Carlo. Okay, we checked, we brought the data in, we stored it in a proper storage, and we did the transformation that we need, and also we did a quality check. What do we want to do next? Well, what's the purpose of the whole thing? Before publication, do the analysis, doing the actual analysis on the data. So at this stage, we have the data analysis part. Some people call it business intelligence. Some people call it data visualization, which is also a big set of tools. Some of it are paid, like Tableau and Looker. Some of it are open source, like Metabase and Superset. So we have this stack of tools that are coming, as you'll see, from different vendors, and it have a few interesting characteristics that we'll talk about it in a bit. But the most important part of it is how do you connect these layers together? Like, I need something to say, to tell Supermetrics to export the data 12 a.m. every day. And after it gets imported from Facebook, I need to do certain transformation, like store it in my storage, and do certain transformation, do the quality check, and then visualize it in my report. I need to automate that. It doesn't make sense that I need to go that by one by one. And there is actually, this is the last layer of the modern data stack, which is the orchestralization layer. And these are the set of tools that connect all these tools together and make sure that they are working in a proper way. And one of the most famous ones is like Apache Airflow, which is an open source, and there is like a cloud implementation of it, the Google Data Flow. And there are also another tool like Droparo. Dagstar is also a very good one. So this is the big picture of what is the modern data stack and how all of that is fitting together. And I try to start from the beginning to show you the real value of every stage and why do you need it. So what is the data stack? In a nutshell, it's a scalable, low barrier to entry group of technologies that startups and enterprises alike can adapt to drive immense value from their data. And there are a couple of keywords that I want you to focus on in this definition and what we said in the previous slide. So these definitions are scalable, so there is a scalability, and it's a software as a service. So it's something that you do not own usually. You usually pay for it, or you can own, it depends. And also, it has a low barrier to entry. So you could, like just now while we are sitting, you can set this entire thing like literally in 20 minutes. With open source tools or with paid tools. And then it's pay as you go. And this is a very important aspect because the low barrier to entry is also connected that you do not need a lot of money to do it. And then when we say the modern data stack, we usually mean this is a cloud-based. Also, there is a very important part, and this is a platform as a service, and there is a very important aspect, I think it's the most important part of all of this, which is the modularity. That it's not get it all or leave it all. It's get what you need from it. I might need Airbyte to do the data ingestion from Facebook and whatever sources and do that in my own computer. I don't need the cloud or do that on premise. Maybe I have everything on the cloud and I just need, like if you look at any provider, AWS, Google Cloud, any of those, all of them has all these layers included. Because they want to grow their business, they want to look you in. But the modern data stack by definition is against looking in. It's against being looked to one vendor because you can use whatever you want to use. You can adapt, for example, you can either use data prep on Google Cloud, which is a brilliant tool, but you maybe just want to get another vendor and use, for example, let's say any of the DBT and just link it, implement it on a Google Cloud. You can do that. So this idea of modularity is really important because that means you only pick the tools that you need to achieve your work. And then a couple of important things like low maintenance. You don't need to spend that much, especially if you go to the cloud. And also that it's serverless, of course. And you can either use a data warehouse or a data lake, whatever you want to do with that. Now, this picture that I showed to you is a bit simplified version of what we have now. Now, the actual picture looks more like this. So this is the map of the current data stack as of November 2021. And as you see, like if you wonder where to start, definitely not from here. So what I would suggest, like for me personally, when things tends to get more complicated, I tend to run to the other way, which is let's simplify things and go back to the basics. What are we trying to achieve here as analysts? And why does it matter, all of this? Why does it matter to us? And let's start with a very essential definitions, which is what are the data that we are really getting in our work? Well, we have mainly two categories of data. So we have either operational data that we use to run the business, which is the customer's data, the product's data, whatever essential data that you need to run your business. It's very essential. And we have the analytical data, which is what you use to optimize the business and to optimize the user experience. And with those two stages of data, and most of us are really operating in this side here. But the question here that you might wondering, with all of this, with all this massive explosion of tools, how do we get data from here to here? This is all what we are really trying to achieve. It's really as simple as that. And for that, we use what we call the Etl Operations. So we do extract. We extract the data from the sources. And we do some sort of transformation to make this data available and accessible to us in a proper way. And then we load the data into some sort of analytics tool, business intelligence tool, storage, and whatever you want to do. Now, this has been the mindset and the paradigm of where we have been living for many, many years. But there is a problem embedded with that model. There is actually a couple of problems. Can someone say some of it? Any ideas? What's the problem of like extracting the data from the sources, do transformation, and load it to where we want to do the analysis? Like, just imagine you want to get someone is asking you to do some sort of analysis for the ROI of your ad spend. So I will ask my engineers or whatever, give me the data from the Facebook ads and transform it in a proper format. Just join things together and remove bad tables and bad fields and everything, and fix the formats and everything, and then load it into my somewhere where I can connect to Tableau or any other analysis tool to do it, which sounds good. So what's the problem?
Time-consuming.
Sorry?
Time-consuming.
Time-consuming, okay. Maybe, sometimes.
You don't have the raw data.
Sorry?
You don't have the raw data.
You don't have the raw data, okay, that's a good point.
The ability to do it accurately.
That's a good point.
Different teams managing the different sort of pools of data.
Yes, exactly. So that's the point. If you think about it, you think from, you think from an organizational perspective, who are the people that do these operations? Who are the people that are sitting in each one of these stages? Well, in some companies, you might have different teams that do different things. But in most companies, it's usually the same team, which are the data engineers or analytics engineers, or maybe if you're less lucky, it's the IT people. So you have, this problem of having people that do not understand the domain knowledge, who have to do the transformation for this data to make it accessible for you, which consumes a lot of time, and it's not very efficient, and end up with a lot of troubles, ending up with the data that you do not need. So this is where something interesting started to happen in recent years, which is someone came and say, not someone, of course, the community, but someone says, why don't we switch those two together? What happens if we do the following? So we do the extract and load. I want you, you're my data engineer or my IT person, I want you to load the data to me as it is in its raw format and leave the transformation to me. Because I know the data. I need to be able to do the transformation myself, because if you do that, that's a permanent change to the data. I cannot get the raw data in. And when that happens, something interesting started to emerge, which is that those both together went into what we call the data engineers that oversee the pipelines, make sure that everything is working across the the different platforms, oversee the API connections and everything. And then who's doing that? Well, sometimes it's the analyst, and sometimes we have this growing field of what we call the analytics engineers. And I think this term was coined by DBT first, but it's growing increasingly, and it's getting a lot of attention, where we have this interesting skill set of people that are close a little bit to software engineers. So they have a lot of the software engineering skills and a lot of software engineering practices, like version control, like deployment, production, staging, etc. But on the same time, they are also analysts. They understand the data, and they are very close to the actual analysts that are the domain experts. So we have those two fields that started to grow. And with that, we have this, we hear news about this, that, data engineering is getting more interesting, and we see in recent years, like, massive increase in people looking for data engineers, and there's a lack in the market of having this kind of, like, all-in-one data engineers that know everything. And also we have the rise of the analytics engineers that started also to get more attention. So where all of that is leading us? Well, I think there are 7 key areas that are crucial to shape the future of where all of this is heading, and actually it is affecting us nowadays. And I think the first one is what we just talked about, which is the rise of the analytics engineers. So I think with platforms like dbt getting more popularity and with the rise of the community that supports all of that, I think there will be more demand and more space in the market for what we call the analytics engineers, which are the people that have the technical ability, that have some sort of software engineering background, who knows how to bring the data in, but also knows how to do what the analysts require for the data at the end. And by the way, dbt, how many of you use dbt? No dbt. Okay, so yeah. So I think one of the most important things that I would highly, highly advise you to look at is check this tool. I think this is one of the greatest innovations that happened in the data industry in recent years. And the idea of the dbt is really simple. So dbt is data build tool. And this is what it stands for. And the idea is really simple. It says, you know what? You remember this diagram where I showed you the ETL, and now the analytics engineers need to do the transformation. Now, how do you do the transformation to the data? Just imagine that. My data engineer, he's a software person, and he brings me the data into my data warehouse, and I need to deal with it, but I don't know how. What kind of skill sets does it require for me to do that? Maybe some Python skills, maybe some software engineering skills so I can access the data, maybe some sort of version control skills. But dbt got and said, you're an analyst. What do you know? Well, I know SQL, probably. Okay, what if I give you the ability to use SQL to do some sort of software engineering? Which is really interesting and makes sense when we look at it now, but it is really innovative. So what dbt did was they came up with their own version of SQL, and you just write this code in some sort of templating language that is really simple to understand, and then dbt under the hood will transform that into specific data warehouse technology SQL. Because also, like if you use Redshift, it uses a different SQL from BigQuery, it uses different SQL from other vendors. So dbt is doing the transformation for you. It's not a massive change, but it's a different version of SQL. So dbt is doing all of that with you, and it comes with a very interesting thing, which is a very strong community that is supporting the tool. And this community is providing a lot of connectors. So now when we talk about Airbyte, there is an Airbyte model for dbt that you can just load into your dbt workflow. And it has also version control. It has deployment and staging, etc. So I think it's a brilliant tool. And the analytics engineer, as dbt defined it, is, it's the person who provides clean data sets to end user, modeling data in a way that empowers end users to answer their own question. So you feel this is getting closer to the analyst, but also this is, in some degree, actually a developer. So I think there will be a growth demand into the software engineering skills. That doesn't mean that you need to learn software engineering if you do, but I think this skill set is very crucial to your organization. And the developer, as always, will be your best friend. Either you be that person or you get the person that can do that. The other part, if you remember the diagram that I showed to you, is what we call the reverse ETL. So what is that? Let's go back to the way we described things before. So we extract and load data, and then we do whatever tracking we have, and then we transform the data, and then we visualize it. But what happens after this visualization? What happens after you do the report in Tableau or PDF or presentation or whatever? You provide some sort of recommendations to the business to act on it, right? And in a lot of situations, this is not really effective. This is a waste of resources and a waste of time. So what if we have the ability to take the data back directly from the outputs of your analysis back into operations to inform something in your Shopify store or your CMS or whatever you're doing? What if we have this ability? So this is where we have a growth of something called the reverse ETL, and some people call it operational analytics, where you take the data back, you take the output of your analytics work and put it back into operations. And this is what we call analytics data activation, but this is like automated, like fully automated data activation. And one of the best tools that is doing that is Senseless, and they have like a really interesting features. I think there is 2-3 tools in the market now that is also open source, but I think this field will grow significantly in the coming years. The other thing that I think will be also growing, which will be also interesting, is this barrier to ELs will become much lower. So ELs is the extract and load. And tools like that like Airbyte, this is the tools like Supermetrics, where you can connect to different data sources and then get the data into your data warehouse. I think there will be a massive growth in this field, and I think Airbyte is really one of the best tools that is getting up a lot of momentum in recent years. And if you've been using Supermetrics or other tools, I would highly recommend that you look at Airbyte. And for these tools, we'll talk a little bit about the open source later, but for these tools, it provides you the ability to deploy their systems completely for free if you have the technical knowledge, or if you don't have the technical knowledge, it can provide like a paid service. So I think this will continue to grow. And then just imagine that. So we have more people using data, and we have, it's really easy for you to extract and load data with tools like Airbyte. We are getting into some sort of a trouble, which is that we need more governance and more data security. And maybe this is the least favorite part for most of us, but this is really becoming essential, because now you're thinking, okay, my team, anyone in my team, my analyst can just use Supermetrics or other tools to load my Facebook ads information. Maybe this is sensitive information that I do not want to share with anyone. Anyone can now use Shopify APIs to bring the customer's information into some sort of database. Who can do that? Who can access the data? Where is it stored? How can we secure that data? So with that massive growth in tools, and with the barrier going lower and lower, there is a problems increasing with that requires a different way of thinking about data governance and security. So that's also something that I think will be really interesting happening. And we see examples about that. Like if you are not pushed by your team for security purposes, you will be pushed by the government. And if you are not pushed by the government to do something, you will be pushed by people that is demanding more control over the data, and they are caring more about their privacy. And the next thing is about the data culture. So how all of that is really powered, all of that requires a lot of changes in the way we work, and going through ETL or ELT or implementing a reverse ETL in our operations. So this is a very interesting report that I advise you to check, and it says that 92% of enterprises that was surveyed says that data culture is the biggest challenge to being data-driven organizations. And I think there is many aspects of that that are really important, which is about the people, which is the skill sets that we need to implement all of that. And also it's about the processes that we may ensure that all of that is working properly, and change management. And the last thing, not the last thing, but before the last thing, I think this is also one of the very interesting trends that is happening also in recent years. So let's go back to the data lake issue. You see, we discussed the problem with the data lake, and part of that is that we have this team of data engineers or IT people or software engineers that are sitting in a closed room, have no idea what we are doing with the data, and they are asked to bring the data in from somewhere. Have you been having this experience with a data engineer or software engineer where we are requiring them to bring some sort of data from Facebook, and it doesn't make sense, or there is a lot of empty fields, or the data doesn't fit with what you're seeing in the Facebook reporting API or like interface? Have you been in this situation? The thing is, they have no idea what you're looking for. They just see that the API call is bringing like a positive acknowledgement and everything is good. So they have no idea about the context, and this is really problematic. So we have this new way of thinking, this new paradigm of thinking about things, which says maybe the data lake is not the best approach. So what should we do? Well, we should do 4 things. This is what is proposed in the data mesh. First, it focuses on bringing data into what is called the data owners. And with data owners, it says basically, your marketing team should be the owner of the marketing data. The sales team should be the owner of the sales data. And, whatever team, operational teams is responsible for the operational data. But this is a problem, because that means that we are basically creating silos. Well, that also includes that the ownership comes with a responsibility of providing your data as a product to other teams in your organization. Does it make sense? Like I say, I'm the owner of the sales data, so I own the pipeline. I have skills in my team that supports this pipeline to be fully operational, but on the same time, I'm responsible of providing a way to the marketing team when they require the sales data to be provided to them in a proper way. So this is what the data mesh is basically saying. This actually requires another 40 minutes, so it's a very big topic, but I would highly recommend that you check this book. For Zamak, she's one of the key advocates of the rise of the data mesh, and I think this will take a lot of attention in recent years, and it will have a significant impact. Now, this is not perfect because, like if you think about it, so now instead of having one analytics engineer and one data engineer in my organization, I need a data engineer for every team? Yes. And it has a very high cost of skills that you will need to get. It has a lot of responsibility of making sure that you are connected with your teams and your data is really available as a product. But I think this is a very interesting approach, and I think it will gain a lot of attention. And the last thing is the growth of the open source solutions. Now, I think like we are not in, we are beyond the era of buy it all or like open source it all. I think we are in an era where you can mix things with this idea of modularity is really key to everything we do. I think you will need to look more into the open source community. There is a massive growth. Like if you look at Airbyte, it's like, in my opinion, way more sophisticated than Supermetrics and other paid tools. It has a growing community. It has a lot of support, and it has a paid version if you want to, but it's also available for free if you want. So I think this is like the map of one of the tools, like some of the tools in the open source data stack, and I think there are many, many more that is coming every day. Okay, so final thought. You know, with all of this in mind, I want to refer to something that Steen actually said a couple of weeks maybe ago when he said that, you know, like data without action is just a cost. And if you think about it, and also I think Jente said yesterday that data, is not sustainable. Just keep collecting data is not sustainable. And if you think, I remember like many of us have read this article that's saying that data is the new oil. And I think in an ironic way, it's really replacing oil and its footprint, like carbon footprint and its impact on the planet. And if you think about it, you know, like we used to live in some sort of like in our rooms, and we think that when we do something on the cloud, it magically happens on the sky and things appears to us. But in reality, this is not what's happening. What's happening really is that our data is being pushed into massive data centers that consume a huge amount of energy. And this energy has a massive carbon fingerprint. Like this is one of the research that was done, I think, in 2019, that says that training a language model can harm the environment just for one time, can harm the environment more than a car in a year. So just imagine how many models are we, training every day, and just look at the massive, insanely scale, GPT-3 and these kind of models that work with trillions of parameters. So I think this is one aspect that we can look at. And if energy is not convincing enough for you, then I would suggest you look into another very dangerous aspect of data centers. That is the water consumption that these data centers are using across the globe. I was just watching like a report a few weeks ago about some of the villages that was affected in the US, in some of the states, with data centers around them consuming massive amounts of water from the lakes that they don't have much of. And I think the data center, in average, consumes around 1.5 to 3.5 million gallons of water every day. So just imagine that, these water that we really need, and we know there is a scarcity of this very precious, resource for us, is being used to cool the machines instead of giving it to people that rely on it for survival. So I think this is a very important aspect with everything we speak about in the recent years, so in the recent days, and with this, of us acknowledging that just getting more data is not enough. And even if we have all the data in the world, we will just need more. And instead of just focusing, okay, how can we get more of it, we need really to think about it, how to get less of it, because it's really important for our survival. And thank you.
Oh, wow. This was really strong, both like from data perspective and, planet perspective. So thank you very much. This was a great talk. Two things that resonated the most personally for me were activating data, bringing it like back into operations. And you mentioned that there are like only a few companies so far that can help do that at scale. Why do you think is that? Like why, it's not a red sea yet or red ocean?
Yeah. Well, I think it's just because how things grow into this area where we have silos of software people that talk with the APIs, know how programs are talking with each other, how to talk the databases, and then we have, who build these CMS and, e-commerce platforms, and then we have the analysts who sit in this dark room trying to to figure out how the business is working. So I think it's just about that idea that each one of these groups has grew to be silos, and now there's a connection. There is this question of, okay, like, how can we put that learnings back into the platforms? It happened to a certain degree with some of the platforms. Like if you use, for example, Salesforce has bought Einstein Analytics, I think 1 year ago or 2 years ago. And within Einstein Analytics, you can put back a scoring into your customers. So this is a feedback loop where you just do that scoring, and through that scoring, you can create an entire journey for your customers. If they are engaging, what is the average order that they are buying, etc. So all of that, that's a good example. But this is the problem of a vendor lock-in. With a modern data stack and this growth of ETLs, it's giving that to you on scale with an open source, with this idea of modularity, that you can just take whatever you need and put whatever you know. So I think this is definitely one of the most growing fields in the coming years.
Thank you. We have 5 minutes for questions, so if there are any, please raise your hand. If there are not, I can ask one more then. Oh yeah, sure. Going your way.
Super inspiring, Ibrahim. I really took note of one little thing on one of your slides that said data is a liability. I think that would be interesting if you elaborated a little bit on it, because it's something we never discuss. We talk about privacy, GDPR. I'm going to talk about it tomorrow in the blockchain context. But really curious to hear your thoughts on how do we handle that liability.
Yeah. Well, I think like especially with the privacy laws, we know now that we need to figure out this new world of less is more. We are getting less data. And ironically, we have more data sources, but somehow we are getting less data out of these data sources. I mean, just see what you could get out of Facebook 2-3 years ago. Now when you do advertising, you cannot get even the size of the audience that you are targeting, and Facebook doesn't allow you to access all of this data, and you don't have much option. So I think if you look at it, we need, first of all, as analysts, to change the way we look at things. And we have this mindset for many years that give me as many data as you could, and I'll figure out what to do with it. And this is the same mindset that created the data lake at the first place. Just put everything in one place, and we will just innovate later. But now I think we are moving into this direction of, I don't need all the data. I need enough data to give you value. And I think this is one interesting shift that is happening. This shift is mainly pushed also by regulations. You need to justify why do you need all these data. If you think about, for example, web analytics, with many aspects, if you think about the data points that Google Analytics is collecting about us with each head, you might never need the screen size in your operations. You might need that for, like post exclusion and everything. But what I'm saying is that there are a lot of data that we never questioned why it's there. And I think we are at the stage where we need to question everything. If I need to get this data, I need to know exactly why would I need this data for. And it's a little bit challenging, and I think it's a little bit risky because, okay, what if I don't know maybe it will be useful later. But the thing is, you're not allowed to do that by law now. You don't have something in law that says I might use it later. It doesn't make any sense. And now with this environmental impact of data, I think it's very important. Maybe for us, for this group, we might not have that significant impact on the data consumption compared to, like Google or Facebook. But I think we have in this room, like a group of the finest minds of analytics in the world, and many of the people who advocate for things. And then I think we can have an impact if we say, let's go for this data. And another thing that I want to talk about, it's a little bit controversial, maybe a lot of you will hate me for it, but I think there is a big difference between measurement and counting. And in a lot of situations, what we need might be just counting. And it's this idea that, we keep pushing for data and we say, give us all the data that we have and we will give you all the interesting insights. And then what you provide at the end is just a report on page views. And this is all what we really need. So if this is all the thing that you need, page views is just a count. It's a sort of count. You don't need to track everything. You don't need to use cookies. You don't need to track signed-in users. What if the value that you can get for your users doesn't require sign-in? What if having this journey from checking the product into buying the product doesn't require any friction, and you don't need anything from the user after that? So the question here is, we do this for living. We need more data for living. But I think we are at the moment where we should really question that and focus about the value that we are really providing to our organizations.
Thank you. Fred, if we could pick it up later because we're a bit short in time, but I'm sure there will be more questions today at the lunch and at the bar in the evening. So thanks so much once again. This was very inspiring.
Thank you.